All right, so now that we've graphed our sine function up here, I would like to graph the cosine function. So let's go ahead and move on to cosine. So graph of cosine. So we'll take y equals cosine of x. I'm going to do the same idea that I did with my sine function, and I'll go ahead and draw my x and my y axis. And I'll make a t-chart to determine what values to stick into my graph over here. So I'm going to use the same values. I'll use 0, so when I take cosine of 0, I get 1. I'm going to use pi halves. When I take cosine of pi over 2, I get 0. When I stick in pi, then I take cosine of pi and I get -1. When I pick 3 pi halves, cosine of 3 pi halves will give me 0 again, and then I'll go all the way out to 2 pi and I get cosine of 2 pi is all the way back around to 1 again. All right, so let's go ahead and plot those points. We're going to need a scale on our graph here, so I'm making my scale the same way I did with my sine graph. There's my pi halves, here's my 3 pi halves. Let's go up to 1 and down to -1 again. And so I'll pick my points. So my first point is 0, 1, so it starts up here. Then I have pi halves and 0. Then I have pi and -1. And I have 3 pi halves and 0. And I have 2 pi and back up to 1. So those are my different points. I can pick one more point just to make sure that it rounds off. So let's put in pi over 4. So we have our cosine of pi over 4, and that'll give us root 2 over 2, which we learned in the last video comes out to 0.07. So when I pick that point, it's going to be right about there. If I go to the negative version of that point, or if I go over to 3 pi fourths, then it turns out to be a negative root 2 over 2. And so I'd end up with a point right about here. So it looks a little bit different. Let's go ahead and connect those dots. And so here it goes. It swings down, it comes back up. Should probably come back up a little bit nicer there. Then I'll swing around again. And it'll go back down after that. Same over here. It's going to come back down. It'll have that repetitive motion again. So if I were to go out here to the left, I could go out to 2 pi again. This is -2 pi, and then I have -pi. There's my -pi halves and my -3 pi halves. And so I'll end up with very similar numbers here. And I'll end up with 0 right there at the halves. And then with my -pi, this time I'll go down to -1, and with my -2 pi, I go up to +1. And so if I continue my graph here, I end up with, gotta get it through the point, come in like this. And so it makes that same sort of wavy motion that we saw with the sine graph. All right, so with this graph, I want to notice a couple things again. So first of all, our domain is all real numbers. It goes from -infinity all the way to infinity. On our x-axis, there are no gaps. There's nowhere where it just doesn't work. The second thing is that my range stays between -1 and 1 inclusive for both of those. My third thing that I would like to notice is that, again, my x values are in radians. I'm using radians, I'm not using degrees. Radians are real numbers. Again, it is repetitive. This repetition is a little bit harder to see because it doesn't start at 0 and then end at 0. Instead, what it's doing is it's starting at 1 and then it's ending at 1 again. If you would like to, you can move it over and start right here at that negative pi over 2 and then end at 3 pi over 2. That's just a little bit uglier to look at. So I like to say it starts at 1 and then it ends at 1. And so it makes that big gulf that's just happening there. So it is repetitive, and again, it's fundamental period. Which I told you last time is represented by a t is equal to 2 pi again. It takes it 2 pi to get through that cycle. All right, so that is the cosine graph. Oh, I forgot there's 2 more points. Okay, so my next point is that my function is even. It's an even function. And remember, even functions are symmetric about the y-axis. So it is symmetric about that y-axis. If you were to cut it along the y-axis, you could just flip over the right side onto the left side and it would match perfectly. So it is an even function. And my last thing is it has an amplitude of 1. All right, so if you look at that amplitude, the amplitude is always going to be positive, so it comes from down here at 0 all the way up to 1. Remember, it's your difference between your maximum and your minimum point cut in half. It's that crest of the wave from sea level idea. So there is my amplitude. Those are the 6 points of my cosine function. So if you look at this function and you compare it to the sine function that we just worked with, you will notice they look very, very similar. In fact, they are the same graph. They are just, the cosine function is just shifted over a bit. So where the sine function starts at 0, it starts at 0. The cosine function starts at 1, but its 0 point, its first 0 point is at pi halves. So cosine is the same as sine, it's just shifted over pi halves. Any graph that looks like this, that has this similar look, is what we call a sinusoidal graph. So, or a sinusoidal function for general. So a sinusoidal function just means that it resembles a sine graph. If you were to take a sine graph and you were to shift it or you were to move it around a bit, then you should end up with what graph you're looking at if you have a sinusoidal function. So again, it's sinusoidal because it has that same shape as the sine function. And so these two graphs are the biggest graphs that are sinusoidal. You may run into others in the future, but both the sine and the cosine graph are considered sinusoidal functions. All right, and that is it for this video.